Hmm? See. Anybody's out there in the comments, go ahead and let me know when you can hear me, maybe.
There you are, rubbing your eyebrow.
Okay. It's like people. Got a few people. Oh, okay, there it comes. All right, sweet. Excellent. People are coming in. Looks like it kicked everybody out for just a moment, and people are rolling back in. Cool. All right. Excellent. All right, so comments coming in. Fantastic. If everybody hear me okay, just throw a comment saying you can hear me, so and we'll get started. Okay, good audio. Sweet. Excellent. Looks like everybody's coming in. Sweet. All right. Okay, good morning, everybody. Thanks for coming back for another round of live streaming. It's funny because the minute I hit the go live button, I had a weed eater, a lawnmower, and something else outside all kick on the neighborhood. So hopefully not too much of that's coming through. So today what we're going to do is look at trying to take a little bit of the PCB stuff that we built last time up to kind of a higher level. And it and just kind of if you weren't here for the last stream and you didn't get a chance to play with KiCad with us, that's fine. If you don't know why you're here, we are going to have a live stream involving a software called KiCad, and it should be in the description. Hopefully, there is a link that will take you to the website with all the links to download KiCad or KiCad, however you want to pronounce it, and a list of kind of instructions there of things that you want to have ready. But we'll be going through and, like I said, building a circuit. But at the end of it today, you'll have a PCB that you'll be able to manufacture, actually, if you wanted to. And so that's kind of the point of the day, is to kind of get into some more advanced features too. So we're going to bring in a chip this time. We're going to bring in a logo from the outside and look and see how to do that. We'll do quite a few different things than we did last time and kind of up the complexity. But it's still, like I said, if you weren't here last time, you'll still be able to follow along pretty well. It shouldn't be too bad. Before we get started, I kind of wanted to point out a few things. So I'm going to shrink my head here down. Let's see, put me in the corner. Oh, and make it a little smaller. Sweet. Oh, and one other thing is we may have some delays occasionally. It looks like just keep an eye on it to make sure it doesn't fall out. For some reason, the bandwidth's a little shaky this morning, but hopefully it'll keep up with us. A couple of announcements that might interest some of you out there. Today, there is a couple of pieces of hardware that have dropped either yesterday or today that might be of interest to a few of you. So I use a particular product called the Teensy quite a bit. It's a microcontroller. It's programmed with Arduino software. So if you were around for the live stream where we programmed up a Teensy, you'll remember how we kind of did that. We put some commands on it, and what it is this board will auto type stuff for us. So it's a pretty powerful tool as far as preloading commands and things up on it, sticking it in the USB drive. The computer sees it as a keyboard immediately if you set it up that way, and then it just starts to type whatever commands you want it to execute. So that was the Teensy 4.0 that we went over. Well, they released a Teensy 4.1 board, and this is an absolute monster. Now the Teensy 4.0 was a monster in itself, because like here's all the other Teensies and Arduinos and stuff that were ever kind of released, and the processing power that was in those particular types. And then the Teensy 4.0, you can tell, you know, it's got a Cortex M7 600 megahertz processor in a board the size of, you know, a little bit bigger than, you know, or a little bit smaller, and 2/4 put end to end. So Teensy 4.0 was just an absolute beast of a machine. But they've upped it with the Teensy 4.1, and this one's about the size of, say, 3/4 stacked end to end. But the thing that makes this so much better is that, for one, like its predecessor, the 3.6, it has these little holes here on the deck, which is a USB host controller, which means that you can plug a USB device into this thing and then plug this chip into a computer, right? So you could effectively have this sitting between a keyboard if you wanted to. You could have it playing host to an accessory, right? So you could, you know, put a homemade joystick on this thing and then have it send commands through the board to the computer. So, I mean, there's a ton of flexibility there. They already had that in the Teensy 3.6, but the thing with this is that this has the processing power of the 4.0. It also has 8 megabytes of flash memory in it. On the back of this thing, there is expansion slots. So it doesn't come with these 2 chips here, but you can add these 2 chips to add more memory to it if you wanted to. And the big thing is this, is that it's got slot for Ethernet. So if you take a look, there's about 6 pins right here, and you can drop some pins into those. And give yourself an Ethernet connector for this thing. So now not only is it a USB client, a USB host, it can mimic any human interface device. It now has the ability to be put on the network as well. So it is a very, very powerful piece of machinery, and it just blazing speed as well. So if you want to get one of those, play around with it. There is a lot of different applications, both offensive and defensive, this thing can be used for. Very beautiful piece of hardware though. And even for hobbies, right? Like if you want a controller for a robot, or if you want any sort of thing, there's just a really good, a really big market for something like this. And now that it has internet connectivity, it's even better. So yeah, take a look at it. It's cheap too, 26 bucks. It's incredible. The other thing that's coming out today, and which I'll probably be watching the live stream of later, is the Hack 5 Key Crock. They just released it, I believe, this morning, and they're going to have a live stream for it. I think at 1 o'clock today, 1 o'clock Central, I believe. Excuse me. But it is an interesting piece of hardware because, once again, you can put this in line with a keyboard and it will log keystrokes. It will allow you to remote into it and pull those keystrokes off over Wi-Fi. It will allow you to inject keystrokes. Also, this thing is built on the platform of the Bash Bunny, so you can change it almost like a Teensy as far as like what you want it to emulate, like what kind of device you want it to emulate. And they're even talking about you can pair this up with another product they have called the Screen Crab, which is a screen intercept device that you can remote into. So now they're kind of plugging this that for $200, you can buy a package from them where you can put both these devices in line with a computer and have full control of it. If somebody has a password on it, well, don't worry, because you're going to intercept the password with this device, and you're going to be able to see when they log in and out with the other device, and when they've logged out and logged off the machine and kept it on, then you're going to be able to log back in and do any kind of dirty work you want. So interesting device. It's got a lot of the Hack 5 kind of touts that they have a payload, a bunch of different payloads and stuff that go along with these things. So you're not just buying a piece of equipment, but you're buying different payloads to run on it, so it can be a different piece of equipment all the time. If you want to store stuff locally and you don't want to remote it out, there's a button on the top that you can press to turn this thing into a a USB device once you get it back and get all of the screen, get all the keystrokes off of it then. So pretty interesting device, and it's kind of interesting to me that they dropped within a day or two of each other. So both of these are well worth a look. The last thing that kind of found interesting was, and this is kind of a separate thing, but on Hackaday they released kind of a thing talking about how to get free cloud storage and how you can take Google Sheets and do some interesting work with it and make it to where you can send data to Google Sheets and set Google Sheets up as kind of a web app to capture that data as it comes in, and it'll just start listing it for you. So some interesting vectors there to take a look at. So if you got time, head over there, read the article. It's a really good one. Neat project. What they did is they took a temperature sensor and stuck it on a Raspberry Pi and had it just upload to Google Sheets on a continual basis, so it could take time, temperature, humidity, all that kind of stuff. But implications can be further reaching than that. So kind of an interesting read. But yeah, so interesting stuff happening in the world. So if you get a chance, take a look at any one of these. Lots of capability there, and lots of things to keep you busy as far as getting your fingers dirty and some stuff. Cool. All right. So let's see. We got about 24 people with us this morning. Great. And I think what we'll do is we'll jump into today's content. I've got a circuit set up over here. I'm going to pop up the video, or pop up yeah, here we go. Hopefully everybody can see that. So I have here, let me turn the light on. Here we go. Okay, maybe that helped a little bit. So this is kind of the circuit that we're going to be building today. I dropped the parts list for all of this on the website at the link in the description. So if you're curious about the parts that are kind of put together, I'm not going to go through much as far as kind of the electronic side of this. We'll go over a little bit, look at the schematic, and kind of figure out what's going on with it. But just to kind of show you what this is, it's just a simple blinking circuit. So you've got a chip here in the center that kind of keeps timing, and it relies on some resistors and capacitors over here on this side. And as it's keeping time, it has an output on the third pin on this side of the chip. And that output does something where it will push voltage down the line whenever it goes high, and then whenever it goes low, it will take and go to ground. So it's the output pin is constantly switching between going to ground and pushing voltage. And so what you can do is you can have some LEDs on one side in a configuration where it takes it whenever voltage is being pushed out, it takes advantage of that, and it lights one of the LEDs up. And then whenever that pin goes to ground, you have another LED on voltage, so that LED lights up and the other one goes dark. And so kind of the way this turns out, just remove that, is you end up with a little blinking cycle here that goes back and forth. And this just run off a little coin cell battery. I believe this is a CR 2450. Kind of lost connection there. Yeah, CR 2450. So it is like your normal little coin cell batteries, except it's got a little bit more juice in it than the I think it's called a 2032 coin cell. Both of them are 3 volts. It's just that the 2450 has a little bit more capacity than the 2032. When you're looking here, yeah, all we're doing is there's the 2 little, I can turn this over. There's 2 little stems on the bottom of this battery. I'll show you how this looks. So one of these stems is positive, one's negative. And so you just drop it in the holder. I just dropped it across, power and ground here, and it just starts right back up. So a simple little circuit. Kind of show you, bring up the schematic here. We'll turn this off for now. Pop that out. Let's see. There it is. All right, cool. So this is what we're dealing with kind of this morning. See if I might be able to zoom it in, but I think that might be good enough. I think people can see that. Grab my pen here. So yeah, so this is the thing that we were just seeing. And this is the schematic that we're going to kind of make in KiCad this morning. So what we've got is we've got a battery that is powering everything. And I explain a couple things here with what we're looking at. Is our battery is kind of floating over here. And what I've done is I've put these labels on it that say BAT plus and G and D. And pretty much anywhere you see BAT in the schematic or you see G and D in the schematic, these labels are just shorthand that mean, hey, connect this G and D to this G and D to this G and D. So it's just saying, so instead of me just drawing wires all over the place, these little labels are just shortcuts so that it reminds me that, hey, this is connected to this, this is connected to this, this is connected to this. And it just keeps me from having to draw wires everywhere. And the software recognizes it as well. So the software knows that this point on the battery is actually connected to this point on the circuit and this point on the circuit. So it's just a shorthand way of doing it. Same thing with the battery up here. We'll get into the thing that says power flag later. We'll do that when we're kind of in the software. But just kind of explain how this works. You got power coming in here on pin 8. And so, like I said, this 5-5 timer, 555 timer, all it does is keep a beat. So it will go low to high to low to high, and that just, the output just does that all the time. But this output is dependent on a few things here. In this case, it's dependent on R1, it's dependent on R4, and it's dependent on C2. So what happens is when current flows in from the battery, it flows through R1, it flows down this channel, it flows through R4, it flows down this way, and it starts here to charge C2. So you get kind of this flow that's moving in this direction. And what's going to happen is this capacitor is going to charge up to a particular level. Once it reaches that level, which is 2/3 of the battery voltage, but once it reaches that level, you can see here that it's sitting on this pin that says THR, and that stands for threshold. So as soon as this pin detects that this capacitor is charged to a particular amount, what happens is it'll take this discharge pin and it will connect it to ground, and it will discharge all of this capacitor voltage into ground. Once it's completely discharged, it will then start to flow again. And that's what gives you the high and the low, is the charging and discharging of this C2 capacitor. I've got a whole video on my YouTube channel explaining this in like crazy detail. Some people think like a 555 timer is the only thing that I ever play with, just because I've got so many videos on it. But you can tell, if you look at this kind of setup, you can tell why this this output is based on these three components. It's because that when this thing is charging up, and usually when it's charging up, I believe that it's in, I forget if it's in the output state or the input state, because there's more stuff coming, or the low or the high state. But the thing is what happens is as this capacitor is charging up, it has to go through this 10K ohm resistor, it's got to go through this 220K ohm resistor, and that kind of slows the current down as it's charging up C2. So C2 will start to charge up like this. As so as it's charging up, at some point it will reach that threshold voltage, and then when the 555 timer puts pin 7 to ground and it discharges, it has to discharge through this 220 kilo ohm resistor, which takes some time as well. So it's going to discharge like this, and so it's just going to keep doing this little dance up and down. And every time it does that, this 555 timer sees it and translates it into a kind of a square wave pattern out the output. These don't line up, I know, but that's kind of how this works. So one of the things that is interesting about the timing of this is that on the charging side of it, if you set it up this way, usually what you want to do is you want to pick an R1 that's really small, because if you pick an R1 that's really big, what happens is you end up with in the charging cycle, you end up with something that's like this, and then during the discharge cycle, you end up with something that's smaller, right? And so because it takes a lot longer to charge than it takes to discharge. So if R1 is really stinking huge, then it'll take forever to charge this thing up. So you end up with a charge like this, and then the discharge happens like that. A charge, discharge, right? And that's what you don't want a lot of times. You want something that looks kind of perfectly square, like we drew up here, that is kind of equal on both sides. So typically, if you're setting one of these up, you want R1 to be a lot smaller than R4 in this case. So let me clear off some of this. So that's all that's happening is all we're doing is if you take and you if you wanted a different blink pattern than we showed a second ago. So a second ago when we had this thing, the circuit on, we'd see this guy blink and then this guy blink. And they were pretty much lined up to where you really couldn't tell that one was staying on longer than the other. But if you wanted one to stay on longer than the other, what you could do is you could adjust R1 to make that happen. If you wanted them to be faster, you could adjust both of these to speed it up, or you could keep both of these resistors absolutely the same and just make the capacitor smaller. So if you take and you drop this capacitor, right now it's at 4.7 microfarad. If you dropped it down to 1 microfarad, then you would get a greater blink rate, because it wouldn't take as long for this capacitor to fully charge. So a lot of different things you can do to kind of play with this blink rate. But yeah, so really R1, R4, C2. This is all timing. The rest of the stuff after that is just kind of things that have to be there to make the thing, make the circuit work. So there's a capacitor over here on pin 5 that goes to ground. All that's there for is to give you a nice steady output that doesn't vary with any kind of frequency. If you wanted to take that output, that up and down and up and down, and make it kind of vary with frequency a little bit, like so in other words, if you wanted to kind of FM modulate this guy, you could send in a source. Instead of connecting this to ground, you could send in something on this pin 5, and it would cause pin 5 to vary the output a little bit in frequency from whatever you set with these timing mechanisms. So we're not going to do that in this case. We just want things to blink normally. So what you do is you just take a capacitor, push it to ground, and that keeps the frequency nice and steady the whole time. Pin 4 has to go to power. So you stick your battery on pin 4. There's pin 1 has to go to ground for this thing to work. And then the only other thing is pin 2 and pin 6 need to be connected in order to get this functionality. Otherwise, it changes the functionality of the 555 timer entirely. Instead of getting an output like this, what it is you end up getting something called a monostable mode. This is called a distable mode, but you end up with a thing to where it doesn't give you this kind of output until you trigger something. But anyway, in this case, what we've done is we've linked pin 6 to pin 2, and you see this little flag that says link. That is the equivalent of me drawing a line from here to here. It's just that I didn't want to draw a wire from there to there because I didn't want to mess up my schematic and make it look sloppy. So I just put these little flags there to say, hey, link this part to this part. It makes it easier. And then lastly, pin 3, which is here, is this is where your output occurs. This is where you get that up, down, up, down. So at certain points it is high, so the voltage will be, the voltage coming out of pin 3 if I remember correctly, and it's been a while, is always your battery voltage minus 1.3 volts or thereabout. So if this is a 9-volt battery, you're looking at, what is that, 7.7 volts or so. I can't remember if it's 1.3 or 1.6. I have to look back in the data sheet. But it's always a little bit lower than whatever the battery voltage is. So when this thing when this thing goes high, what'll happen is you've got current that flows out. It's not going to go, the current's not going to go up here to where the battery is. The current always wants to go to ground. So you're going to have it flow down here whenever the output is high. And, messed that up there. Whenever it's high, it's going to flow out and down to this LED and turn it on. Whenever it goes low, what's going to happen is this is going to connect to a ground, essentially, and the battery voltage is going to flow down through here and going to take a direct line to ground instead of trying to go through this extra resistor right here. And so now at this point, this LED is going to light up. So we get this kind of back and forth functionality where at one point we're going to light this up, and then we're going to light this one up, and then it's going to go back to this one, and it's going to go back to this one. So just kind of back and forth. So yeah, so that's kind of what we're looking at doing. This is going to be our example for how we're going to build KiCad. So you can take this. Excuse me. You can take this. I think, I'm not 100% sure if I put this on the website or not. I'll need to check. But don't worry if you didn't, because we will kind of go through this. Actually, let me just check that really quick. Make sure it is on the website, or see if it's on the website. And if not, I will give you a solution for that. Oh yeah, it is on the website. Excellent. Great. So yeah, at the bottom of the website, if you want to keep this up and kind of take a look at it from time to time to make sure that you're following along okay, the picture's down at the bottom. Just click save, download it, and kind of keep it minimized on your screen. Okay, cool. So let's take a look at KiCad. So if you open KiCad up, you might see the project that we did last time that might already be loaded there, or you might not see anything. That's fine. What we're going to do is go up to File and go to New, and go to New Project is what we want to click. All right, remember that when you create a project in KiCad, that you aren't just, whenever you create this folder, so I'm going to call this Blinky. Whenever I hit enter now, what's going to happen is it's not going to save all of the project files just in this directory. It's going to create a folder in this directory and then save all of my files underneath that folder, right? And so if I call the main KiCad file, the pro file, if I call it Blinky, it's going to create a folder called Blinky, and then underneath that folder is where it's store Blinky.pro. So we'll go ahead and save that. And now I've got a project open. Oh, is everything okay?
Really significant lag.
Okay, all right. So I've just been informed we have a pretty significant lag. So I think, yeah.
It's just now getting to the website.
Oh, it's just getting to the website. Okay. Yeah, so we're about a 30 or 40 second lag, so it is decent this morning. Anyway, so we'll carry on, and if you have an issue, just pop up your question in the comments, and Brandy will be able to take a note of it for me, and I'll get to it as soon as it pops up. That way, hopefully we can minimize the lag as much as possible. All right, so we've got our project that we've made, and the first thing that we want to do is open up the schematic file. So the first button here of this line of buttons, just above where it says project name, we'll click it, and it will open up. For me, it'll open up a bunch of errors because I have all kinds of stuff in my libraries that are not supposed to be where they are. But you should have a screen that opens up and looks like this. So have a nice blank page here. Remember to navigate. You can use your mouse wheel to kind of zoom in and out of the page. And that's kind of, I guess the big thing you need to remember is that. If you want to kind of refocus on something, it's best usually to zoom out and then zoom back in on it. And instead of kind of using the scroll bars to get around, I find just zooming to be a little bit faster. So on our schematic, the first thing we're going to do is kind of lay out all the parts. So the first thing we'll do is come over to where it says place a symbol. So I'm going to click that and just click anywhere on the sheet, preferably somewhere in the middle, and it will load my libraries and say, okay, so what do you want to load? The first thing I want to load, let's see if we can load a battery. So we'll start with that, start with a power source. And we have a single cell battery that we'll use that one. So you just highlight it, hit OK, and then place it anywhere on the sheet that you want. And then zoom in so you can see a little better. Next thing to do is let's go ahead and place our large chip, our 555 timer. So make sure your place symbol button is still highlighted, and just click again anywhere on the screen. It'll pop this back up, and you just type in 555. And the first thing that pops up is an LM555, and that will be just fine. There's a bunch of different types of 555 timers that have maybe slightly different printouts. A lot of these don't really matter too much. It's just a lot of, some of these have different footprints associated with them, and so people have made different types. But the LM555 will work. If you don't see the LM555, that's okay. Some other piece will probably work as well. But if you've got this one, then choose it. And we'll just place this somewhere in the center. The next thing we want is our capacitors, and it looks like we need 2 capacitors to be able to pull off what we want. So click on the screen again. All you gotta do is type C, and it will automatically come up with the capacitor part. So that's good. Now in my schematic, I used one capacitor that is polarized and one that is not. So one of the capacitors actually is polarity sensitive, and the other one is not. And you'll see here you got one that says C and one that says CP. So I'm going to have one of each of those. I'm going to take one that says C, double click and place it, and I'm going to take the other one that says CP, go back in, and we've got a CP1 or a CP. It doesn't matter, either one of those will work. I kind of like the look of CP number 1, but either one is completely fine. I'm just going to double check and make sure. Oh, my piece just disappeared there. But yeah, either one. There we go. Either one of these will be fine. So I'm going to choose a second one. All right. So now we've got our 2 different kind of capacitors. Next we have, let's see, how many resistors are in this thing? We've got 1, 2, 3, 4 resistors. All right. So to place those 4, we'll just click on the screen again. You can just click R, and a resistor will pop up. Like we said last time, this is the normal resistor that KiCad recommends. There's also a resistor, and I'm going to go ahead and type it the rest of the way out. So there is an R_US, and I just like the way this resistor looks. But you can use R or you can use RUS. It doesn't matter. I'm going to click OK, and it's going to give me one of those resistors. Now there is a shortcut key, so if I come back over here, I click on the arrow or just hit escape, it'll bring me to that arrow. What I can do is put my mouse over the top of the component. So we need 4 resistors. Put the mouse over the top and press the C button, and it will copy that resistor multiple times. So every time you press C, you will get another copy of that component, and you can place it down on the screen. So now we've got 4 resistors there. So we got our 2 capacitors, we got 4 resistors, the battery, and let's see if there's anything else that we're going to need here. Oh yeah, LEDs. So once again, we come over here, get the place symbol, select the screen, and type in LED, and it gives us one right there. So I can hit OK, place it, and then once again hit C, make a copy, and place it as well. So now we've got a whole page full of components, and we can start kind of putting these things together in a way. The first thing I'm going to kind of play around with, though, is this battery. So I'm going to go over here, click the arrow key, and I want to move this around. Now, the way that you move a component around is just put your mouse over it and hit M, and it will allow you then to move it. I think you can also, you can't. Yeah, so you can highlight it also and move it around, but I just prefer to hit M over the top and then move it. So I'm going to place this kind of up here in the left. And with my battery, what I'm going to do is kind of do what we did with the schematic. I'm not going to take and run a wire from the top of the battery to every single point on the schematic where I'm going to need the battery to be hooked. I'm going to put a flag there, or an indicator there, and then everywhere I put that little indicator, it's going to give me connection to the battery. So the way this works is over on the right hand side there's a button that's called Place Power Port. So what you want to do is click that Place Power Port button. Come back over here in the middle of the screen and click, and it will bring up something that looks just like the symbol placement feature. But everything in this is all related to power. So what I want is I'm going to get kind of a power, let's just call it like call it a flag, call it a label. But there's all kinds of stuff in here. There's some stuff that's labeled 3 volts, there's some stuff labeled 5. What we're dealing with is we're dealing with a 3 volt battery, but if you look, there's not a 3 volt there, it's like 3.3 volts. Normally though, if I'm dealing with any kind of battery, I just kind of skip these and I just use this thing right here that says power flag, positive battery voltage. So it says plus BATT. You can highlight that, hit OK, and then drop it close to the top of the battery there. The same thing with the battery. There's always going to be on the negative side, you want to have some symbol or flag there as well. And the best kind of symbol or flag you could have there is a ground, or a ground symbol, or a ground flag, right? So if you go back to make sure you have this the power port button highlighted, click, and then type in GND. It'll take you right to a power flag for ground. You can click that guy, hit OK, and then drop it just below the battery. And then if we want to connect those up, what we do is come over here to where it says place a wire, click that part, and then zoom in. What you can do is click to connect these two. So what you do is click on one side, drag it down, click on the other side, and it marries them up. So what that's going to say is everywhere we put this symbol BAT, it's going to connect that to the battery. Everywhere we put it says GND, it's connecting that to ground. There's one more thing we're going to have to do up there, but I'm going to wait on that so we can place some of the other components, and then we'll talk about that. So we're going to kind of go around the horn here as far as figuring out where everything needs to go on the 555 timer. The first thing that, sorry about that. Let me get this thing zoomed in just right. The first thing we're going to do, I'm going to go back here to my mouse thing, is let's start with pin 1. Pin 1 needs to be connected to ground. So I'm going to come up here to this ground label. I'm going to hit C to make a copy. Come down here to pin 1, place it below pin 1, and then come back to wire and run me a wire from pin 1 to ground. So all I'm doing is taking a copy of this, run it. Now what's going to happen is pin 1 is now connected to the ground of the battery. Just kind of that easy. It's going to make that connection for me. So keeps me from having to run my wire all the way up here. The next thing we're going to do is, so we got ground for it, and so now let's place everywhere that we need kind of power for this thing, right? So I know I'm going to need power going in on pin 8, and I'm going to need it going in on pin 4. So let me move some of this stuff out of the way. All right, so to put power on pin 8, what I'm going to do is take this battery up here, hit C to copy it, bring it over here above pin 8, place it, and then I'm going to do the same thing, copy the battery, come over here to pin 4 and place it. Now the thing is, I don't want my battery there. You see how it kind of runs in, the label runs into to number 5 there. What I'm going to do is hit R, and I can rotate this thing around. So I'm going to rotate it around to here, put it there. Just aesthetically, it'll look better instead of having this label doing that, kind of pressing into 5. And you can do that anywhere. You can go to any component, hover over it, and hit R, and it will rotate that component around for you. So next thing I'm going to do is connect these up with wires. Before I do that, though, this label, it says U LM555. This label belongs to the 555 timer component. I'm going to hover above the label and hit M, and that's going to allow me to drag it down to the actual component itself and place it. That way we don't have to deal with that label just kind of hanging out there. So you can do that with a lot of the labeling, is you can hit hover above it, hit M, and then move the labeling around so it's not in your way. So we move that label. So the next thing I'll do is I'm going to take and place a wire. So click the wire, and we're going to take and go connect the battery to pin 4, and connect this battery to pin 8, and we're good to go with that. All right, so we got the ground, we got the batteries in. Let's place some of the resistors, let's say the resistors and the capacitors there. So we have a couple of resistors that are going to go with the LEDs over here on the right hand side. So I'm just going to go ahead and just drop these over here with the LEDs to get them out of our way so we know what we're dealing with. We've got a capacitor that all on its own is going to be hanging off of pin 5. So that's going to be the capacitor that is not polarity sensitive. So I know in the other schematic, if you're looking at the older schematic, you'll notice that I have both of the capacitors as the same type. It doesn't really make a difference in the schematic part of it, because in the layout, I'm going to pick the capacitor that I want anyway. But in this case, I did want to show the difference, that there are different types of capacitors. But the non-polarity sensitive one, so the one that it doesn't matter which way you put the capacitor in, it's on pin 5. So I'm just going to take that one, move it over here to pin 5 or close to it, and I'll put it about right there. You'll see these labels are starting to kind of overlap each other, so I'm going to click on the label, drag it. So this is I should say click on the label. I'm clicking the M button and moving it over to the other side. At that point, on one side of this capacitor is connected to pin 5, so go to the wire, bring it over here, click on pin 5, and go there. And then what I'm going to do is, this is also connected to ground. So I have a choice. I can either draw a wire from here to this ground lug, and that would be perfectly fine. Or I can just hit C over here, copy this, and place it below the capacitor. And draw me a wire here. So now I've got a my capacitor pushed to ground there. So if I'm going too fast, or if I need to slow down or go over something, just let me know. It looks like there's no comments yet, but I'll keep kind of taking a look over there and make sure that I'm not leaving anybody behind. All right, let's see. So that's one capacitor. The other capacitor that we have is coming off of pin 6. So if I take and move this capacitor over here to pin 6, place it. Once again, make sure I got my wire place selected, draw a wire, and then same thing with the ground again. I'm going to press C over it, bring it over, place it, and then draw my wire. So now we've got our polarity sensitive cap sorted. Let's go with some of these resistors. So we've got 2 resistors here. One needs to be going between pin 8 and pin 7. So I'm I'm going to pop that in there. So I've got this resistor, and I'm going to rotate it. So I pressed M to move it. I'm going to rotate it around so that it's horizontal instead of vertical, and place this guy right here. Take my wire drawing tool, and I'm going to draw from here to pin 8, and it will, remember last time, anytime you join 3 wires, it creates this little green dot, and that's a junction. If you take the wire and bring it over here and place it on another wire and it doesn't create the junction, then you probably missed the placement of the wire. You probably kind of was off by one little node or something, and it didn't make a connection. So when you bring it into another set of wires, just make sure if you have a joining of 3 that actually does that, if you intend for it to join the 3 together. The other side of this resistor is supposed to be connected to pin 7, so I'm going to take it, come down, and instead of just clicking right there, you can see how that would be problematic. It would actually connect pin 3 and pin 7, or make it look like it's connected to pin 3. So what I'm going to do is I'm going to bring it out. I'm going to click, and when I click out here in the middle of nowhere, it creates an elbow for me, so that elbow is always going to be there. So I come out here, kind of click, bring it down, bring it over, and if I wanted to click a second time here, I could do that, just to ensure that elbow is going to stay right there, and then bring it over to 7 and complete it. So now I've got my resistor going from 8 to 7, and then finally we have another resistor as far as timing goes that's going between off this side of the capacitor and pin 7. So I'm going to take this other one. I'm going to hit M to move it. I'm going to rotate it with R and place it right here. And then I'm going to draw from this junction to R, and you see it creates a little junction there for me. And then from the other side of the resistor, I'm not going to just go kind of straight over. I'm going to leave myself a little bit of room. So I'm going to go over just about a couple ticks over, click it, bring it down, click it again, and bring it over to form the junction with the capacitor. So be careful where you place this resistor. Some people, when they're looking at the schematic, and I've been guilty of this too, will think like, oh, well, this resistor goes between pins 7 and 6, so it doesn't really matter if this is kind of, where this is placed. It really does, right? So if this resistor is over here before the capacitor, what happens is when the current flows down through the battery, it goes through this first resistor. It just goes straight to the capacitor and starts charging. If you have the resistor over here, it'll never be part of that charging circuit, and what will happen is you'll have a 555 timer that charges extremely fast and then discharges really quickly as well. So you will end up, what'll it'll look like on your if you have the LEDs hooked up, is either it'll look like neither one of them come on or both of them come on and stay on. So I'd have to think through that to figure out which one it would, but it won't look right. There won't be any variance there. And that's something also to remember when you're working with this thing. If you just have a single LED hooked to the end of it, or anytime you're dealing with a timing circuit, if it looks like the thing is always on, what that usually means is that it is going so fast that your eye cannot tell that the thing is blinking. It's just blinking so fast you have no idea. Or it's moving so quickly it doesn't have enough time to charge the LED up in the first place, and so it's dark. It's been a while since I've played with it, but you kind of see that. I see actually more the former circumstance than the latter, where somebody says, hey, this thing's just on, it won't go off, like it just stays on the whole time. Well, usually that means, oh, that's because you got that thing blinking so fast that it never seems like it's going to go off. Did I just get a message there? Just make sure that this isn't important. No, okay, great. Cool. So all right, so that's how you set up that kind of this far. Oh, we got a question. Can you put the components together without a wire connection? Yes, and in fact, I'm about to show you how I do that. So for instance, the next thing that we have to do is, so yes, Dave, you can do that. What has to happen is, so you could take and make labels for every single one of these components and just have each label refer to another label, and you never have to use a wire. And I'm going to show you how to do that now. So there is a part in here where it says that we need to link pin 6 up to pin 2. And so normally what happens is you could take and you could use your wire. I could come over here, click up here, click up here, click over here, and then bring it into 2. But you see that looks nasty, like that's a big wire. So what I'm going to do is I'm going to delete that, delete all of that, and I'm going to use a label instead. So on the right hand side it says place a global label. It does give you a warning, because if you're dealing with huge like pages upon page, like schematics that are multiple pages, if you make a global label, what's that saying is that, hey, this label is good on every single page of your schematic. This is kind of a small schematic, so I don't really mind using a global label. So I'm going to click it, and I'm going to just click somewhere, and it says, okay, give me the label name. So I'm going to call this label link. All right, and the orientation, let's say it says left. We're just going to see what this looks like. Hit OK. And so we just made us a flag that says link. All right. So what I'm going to do is come over here to where pin 2 is. I'm going to drop it there. And then I'm going to hit C to make a copy of it and come over here to this side. I'm going to use R to rotate that orientation around and stick it here. So now I'll get my wire. So I could take and just, I don't need to draw a wire between the two of them. I just kind of want to show you what it looks like. So that's what it looks like if you draw a wire between it. It links, or it takes and it connects this flag up to pin 2. You can also just take and hit M and just drop it right there on it, and that suffices as well. That's great. So what that says is that anything that's connected to the pin 6 right in this area between this resistor and this capacitor, take anything here and connect it over here to pin 2. So it's just like drawing a wire. So if you're, to kind of go back to the comment there, if you wanted to, you could take a lot of components and just have tons of labels just telling everything where to go. And that happens a lot when you start to look at people who do this more professionally, because most people would look at what I'm doing right now and say, that's a hot mess, what are you doing to these people? But mine's more about function, and I don't do this for a living, so I'm sure there are tons of better ways to do this that I haven't thought through. But if you look at some of the more professional schematics online and some of the stuff that people have built, you see a heavy use of labels. So you'll have a 20-pin component over here with nothing but labels coming off of it, going to a 5-pin component, a 4-pin component, and a 3-pin component, and they don't have wires running anywhere. All it is just labels on each side of it saying where everything goes. So yeah, like labels are really good, really big, and it saves you from having to draw wires everywhere. So that's our label there. I'm going to move a couple of more of these markers. So I've got a resistor, kind of a title and a reference here on this resistor. I'm going to move this down to here, move this R just above it, because I'm going to have a wire flowing right above it here, coming off of pin 3. So I'll take, and we're going to build that out. So the last part we have is the output. Pin 3 is the output, and we have a setup here where what we're going to have is kind of a resistor and an LED, and I'm going to rotate this around. And then above it, I'm also going to have a resistor and an LED. LEDs are polarity sensitive, so remember, if you're talking about conventional current flow, which a lot of people are taught in the US, that you have a current that flows from, say, it's looked as flowing from positive to negative. It's a whole different discussion we'll get into later. But yeah, so what you're going to want to have is you're going to have your battery. The direction of current flow is usually what you would consider the direction that the diode or the LED is pointing, right? So in the case of an LED, you've got this triangle pointing in a particular direction. Think of the current needs to flow, kind of the direction of that arrow. So to do that, I'm going to hit C and copy one of these battery labels over and start drawing my wire. So I'm going to put a wire between the battery and the LED, from the LED to the resistor, and then from the resistor all the way, I'm going to come down, click, and then come all the way over to pin 3. I don't know if everybody sees this, but like if you're not, you see the crosshair on my screen, this gigantic crosshair that just helped me line up this point with pin 3 to go over. If you want that crosshair on or off, you can come over here on the left, and there's a thing that says change cursor shape, and what you can do is turn that crosshair, that gigantic crosshair, on and off. I just prefer to have it on. I don't even know if it's default. It's been so long since I've loaded a default version of KiCad. All right, so continuing on placing the wires, we're going to go from this junction down to here, and that creates our little wire junction. We're going to go from here to here, and then finally, oh look, we need a ground. So I'm going to hit C to copy a ground over for us, and then from the LED to ground. Cool. And it looks like, if I take a look at this, it looks like my head blocked that last, I'm going to zoom out there. There we go. Yeah, sorry about that. Looks like my head dropped, kind of got in front of the ground. Now we've got, I think, the entire schematic. I'm checking over here. I think everything is in place where it needs to be. Good. Now really, we need to do a couple things. The next thing we want to do is, you'll see that these things say, I'm going to change this to a regular mouse. These things say R question mark, C question mark, D question mark. We need to change all of these to actual numbers. So this is R1, this is R2, this is R3. We have to label all of these what they call references to be an appropriate thing. So we could right click on each one and go to edit reference and name them each. But thankfully KiCad has an automatic version, an automatic way to do this. Top of the screen, there's a little button that says Annotate Schematic Symbols. Click it, and there's a lot of options. We don't need to change any of them though. Just hit Annotate, and then hit Close, and it will annotate everything for us. So it's labeled at R1, R2, C1, C2, R3, R4. So beautiful. We've got it all labeled. The next thing that we want to be able to do is we kind of want to let ourselves know what each one of these labels mean. So what I'm going to do is, this R1 is the reference, but this R underscore US is called the value. And so over here where it says on the battery, it says BT1 and it says battery cell. Battery cell is the value. If you hover your mouse over where it says battery cell and hit V, V is in violin, it will pop up and give you a window to change that. So I'm going to change this from battery cell to, I'm going to say, call this 3 volts. So now to change that to where it reads out 3 volts. Down here where C1 is, instead of C, I'm going to put 0.01, and I'm going to put a U in front of it or behind it for micro. So I know that this is a 0.01 microfarad capacitor. Like, this is what needs to be here. If you don't like the U, there's also something called alt codes that will allow you to actually put in the actual micro symbol. So if you press and hold down the Alt key, ALT, the Alt key on your keyboard, hold that down and then type in 230. Type in 230, it will actually drop you a micro symbol in there. So I can put 0. Looks like I just froze up for a second. There we go. Let me come back here. Yeah, so I'm going to put 0.01 Alt 230 F. So 0.01 microfarad. But like I said, if you don't want to remember the alt code, you can just type in, you can just type a U there to remind you. That's all this is, right? Is move this out. This is just to help you when you're constructing this thing and you get it back from the manufacturer, so you remember, oh, C1 was supposed to be this capacitor. Oh, C2 was supposed to be this capacitor. So you don't really even have to fill this out to get the PCB done. The thing is you will thank yourself later when these things come in and you've labeled everything. The next one, R1, what I'm going to do is call this one up here 10 kiloohms, because that's what the value is for this resistor. So 10K, so you can do that. If you want to put the ohm symbol at the end of it, there's another alt code for that. It is Alt 234. So if you hold down Alt and type 234 and then release, it will give you the ohm symbol if you want to put that on your schematic. The next resistor, this is going to be a 220K resistor. So 220K and Alt 234 for ohms. The next capacitor, this is the polarity sensitive capacitor. We'll hit value on it, V. So CP1 will change to 4.7 microfarad, Alt 230 farad. Let's see. All right, and we got two more resistors here. We've got both of these. So I put both of these. You can change these if you want. Last time we looked at kind of making LEDs glow and went through that basic electronics course. We used a 9-volt battery. We're using a 3-volt battery here. And so you can use a resistor that's probably a lot lower than what I'm using. I'm using a 470 ohm resistor, but the only reason I'm using a 470 ohm resistor is because I am trying to save the battery life as much as possible. And so that means that the LED is not going to glow that much. It's going to have a kind of it's not going to be a very bright glow. But what it will do is it will blink longer and it will glow for a longer time because I'm using large resistors to keep it from draining the battery as much. So, in other words, I am barely turning these LEDs on. But I am going to change the value of this to 470 ohms. So 470 and then Alt 234. And then the same thing here, value. All right, cool. So we look over everything, and I think we've labeled everything. Yeah, cool. All right, the next thing we want to do is up at the top, there's something called Perform Electrical Rules Check. And what this is going to do is it's going to make sure that we've got everything connected, that there's not something that's unconnected, that everything is, batteries go where batteries are supposed to go, and everything checks out fine. So if I click Run ERC, or the Electronic Rules Checker, and hit Run, I am going to get an error. I'm going to get a couple errors, actually. So I hit Run, and I get 2 errors. And you can move this thing out of the way and see that one of my errors here, if I click here, is down here on ground, and the other error that I have is up here kind of next to the battery. And it says that pin 1, the power input of the component is not driven. Pin 8. So these errors like dogged me forever when I was first starting out KiCad, because I didn't know like why they'd pop up. I could usually get the thing done and like still like make a workable PCB, but these things would still be just, the errors would stay there, but they never get better. So usually I would use the electronic rules checker just to make sure I had everything connected right and it wasn't anything egregiously wrong. But I can tell you now, I know what these errors mean. So I'm going to close this. And even though the errors are pointed here and here, the problem isn't in those 2 locations. The problem is up here where the battery is. So I'm going to kind of zoom in on this. Anytime in KiCad you're going to use a power source and you have a component like 555 timer that needs power to appear on certain pins, the people who program these components in have said, hey, this is a power pin and this is a power pin, so you need to feed it some power from somewhere. And that's what's throwing the error. Even though we have a battery up here and the battery should be feeding some power in and should be considered power pins, For whatever reason, it's not getting through. So the way you get around that, or kind of the way, anytime I use like a power source, like a battery, in the schematic, what you always have to do is you have to place power flags. So if you go back to where it says place a power port and click it, and then click over here in the field, you scroll down through here and you will find a selection that says PWR underscore flag. If you wanted to, you could just type in PWR at the top and it'll narrow it down for you. But it says power flag general. So if you click that and hit OK, just place it up here somewhere near where the battery is. Now here's the strange part about it is that's the power flag, right? You need to declare both the positive end of the terminal and the negative end of the terminal of the battery with a power flag. So you're letting KiCad know, hey, both of these, the positive and the negative, are both involved in the power system of this device. So I'm going to hit C and copy this power flag and rotate it around and place it down here. Move this a little bit further down. Yeah. Let's see. I want to get this right in the right location. All right. So I place these power flags, come over here to the wire, and I'm going to run it to here, run this to here. So all we're doing is we're labeling this for KiCad to let KiCad know, hey, these are two pins that are going to be involved in power. These two flags here will not show up as something that needs a component, right? It's just something that you're labeling for KiCad so KiCad knows, oh, these are things that's involved with power. So I'm going to come up here to my electronic rule checker. I've got my errors there. I click run. All the errors go away. So that usually trips up a bunch of people in KiCad when they're first getting started is, hey, why am I getting these errors? Is it really going to cause me a bunch of grief? Like, why is there a problem? But that's what the issue is a lot of times. It's just these power flags. You bring those out, place them where your positive and negative terminals are, and you're good. Okay, cool. All right, so let's save this. We probably should have been saving all along so we didn't lose crap. Yeah, so save that. And we're going to go to assign PCB footprints. In fact, actually, before we do that, we're about to get right into the component part of it. We're going to take 5. So we'll come back in at 11:13. So if you need to run the restroom or anything, get a glass of water, go ahead and do that, and we will resume shortly. Cool. Check 1, 2. Okay, I'm going to just put a comment in here. Lag is over 60 seconds. Getting started, but will take a while for you to see. All right. So hopefully, I think the audio is coming in. Yeah, it looks like it is. So what we've done is we have built our schematic, kind of gone over this, put it all together. Now what we want to do is we want to assign components to this schematic. So if you'll notice, I just dropped a link in the comments for a particular website. And let me see if I can grab this off. And it's going to take you to this page, this GitHub page. So what this is this is a repository for components that KiCad carries in its inventory. So that means that you can go here. You can see when the last time they updated it was, say, like 10 months ago. And they've got a list here of a bunch of components that KiCad uses. And one of the components that we're going to use in this is not a stock component. It's not a stock footprint. It is a footprint that it's the battery holder, and the battery holder comes from DigiKey, and so or a manufacturer that uses DigiKey as a distributor. And so what we're going to do is we're going to load some footprints. So to kind of put this in perspective, we've built our schematic. Now what we're going to do is we're going to take every one of those components and assign a footprint to each one of those components. Those footprints will then be put onto the PCB making software, where we will arrange them and put them on a PCB to have that PCB manufactured. But last time what we did is we used all the default libraries that KiCad had. This time what we're going to do is we're going to add one. And I didn't put this in the web page, but I will go back and put this in there in case somebody wants to download it later. I've got a comment here. Almost like half the country is streaming videos right now, or something. Yeah, half the country are streaming videos right now. So that's what we'll do. But if you'll go to that link in the comments and to download this, what you do is you click on the right hand side. There's a button that's green. It says clone or download. Click download zip, and it will download that folder for you. It's not that big. Once it's downloaded, you can take and show it in the folder, and you'll see it's there. Just go ahead and extract that. So just take and extract that out anywhere you want to. It doesn't matter. It'll take a little while for that. Give it a second. And all it's doing is just unzipping all of the different libraries and different things that DigiKey has available. This is not an exhaustive catalog of every component DigiKey has. It's just some of the big ones that people seem to order a bunch of. They have these there, and they've got some good ones there. I've used it for this project, so it's good to have. It's a good library to have around. So you might want to then, once you extract it, it'll pop up and say, look at those extracted folders. One that says DigiKey KiCad Library Master. What you really want though is double click into that, and there's one that says DigiKey Footprints.pretty. What I would recommend that you do just for this project, and you can go back and change it later if you want, but is to take this and copy it into the folder where you are doing your KiCad project. So for me, I'm just going to hit Control C and copy this entire DigiKey Footprints.pretty into my Blinky test folder, which is right here, and just paste it in there. All right, so let's get rid of this, and we're back to KiCad. After you pasted that into your folder, what we're going to do is go up to the top of the KiCad schematic program, and it says assign PCB footprints to the schematic symbol. So click that, and you've got a list of stuff that'll pop up. It'll look like this. So what it does, it gives a list of all the components that we need to assign a footprint for. Before we get started doing that, we need to, I think.
Do you want me to get off of here?
No. Is it? How's it doing there?
It's still running here, but it's a minute behind.
Let's see. Okay, it looks like we're back on. It dropped momentarily. Okay, sorry about that. It looks like it, on our end at least, it popped out for just a second. If you missed that or you missed any part of it, just kind of show you this again. When we open up the assign footprint part, what we're going to do is go up to preferences and go to manage footprints, and it brings up this little box here with all of our libraries inside. So what we'll do is then kind of scroll down. You can see all the different types of footprints there. I've already loaded the DigiKey library, but I'm going to do it again just to kind of show you how it works. I'm going to delete mine out and just show you. So the way you add a library or add footprints into it is you take and click on Add Existing Library to Table. So there's a little folder button here. So click that. And there's two, actually I should say this, let me cancel that out. There's two ways you can do this. For you guys, what I would do is start over here where it says Project Specific Libraries. So you can do this two ways. Either you can go here and add it, and what it'll do is it'll only add these DigiKey libraries to this project. And if you drop the folder into your Blinky project folder, then this is probably the best way to do it. If you drop that folder anywhere else, that like, so you know, pretty much any schematic can get to it, you could put it in the global. But let's do it in the project specific library since that's where you kind of dropped it. So I'm going to put Add Existing Library to Table. I'm going to find my, let's see, I think I might have to restart this. Actually, let me double check, make sure I place this where I was supposed to place it. Oh yeah, I placed mine in the wrong one. Sorry about that. Give me just a second to correct this. There we go. All right, that's better. Let's try this again. So click Project Specific Libraries, click the folder. There is my Blinky folder, and underneath it says DigiKey Footprints Pretty. So I'm going to just highlight that. I'm not going to go into it any further, just highlight it and hit OK. And it has me kind of a nickname there, DigiKey Footprints. I can click OK. And what I'm going to do after I click OK is it's going to think for a little bit. And you'll notice that in the left-hand side now, you have a library called DigiKey Footprints. And this will have all the different modules for the DigiKey footprints that you're messing with. Now I am going to go back. Yeah, so we're good there. So now what we're going to do is start to place all these different components that we need to place. So so hopefully you got this working. You got your DigiKey footprints in there. The first thing we need to place is our battery. So BT1. So the first thing I want to do there for battery is if I go to my DigiKey Footprints library and I scroll down, you will see one that's called Battery Holder Coin 2032 BS7. So I am going to choose this as my battery holder for my battery. If we want to see what that looked like, I can actually highlight it and click over here where it has this little chip with a magnifying glass over the top of it, and it'll show me a little bit of what that footprint looks like. Sometimes, but not all the time, you then can click this little button that says 3D display at the upper left, and it will give you a 3D rendering of what this looks like. In this case it doesn't. All it does is kind of show us the blank kind of like cutout of what it doesn't actually build it up and show you what the component looks like. And that's a lot of the case. A lot of the default KiCad libraries will have this 3D model in there, but the ones that aren't default, a lot of people don't build the 3D model, and that's fine. But this will give us the layout of what our little battery holder is going to look like. All right, so we've got that. The next thing we need is we need a capacitor, a through-hole capacitor. This is the, let's see, it says this is the 0.01 microfarad. So this is the capacitor that is not polarity sensitive. So if we go to capacitors and through-hole, so if we go over here, there's a library that says capacitors, it says through-hole. And on the components list that I picked out, the capacitor I want to use, the one that I want is the C_disk. So you can scroll down here. There we go. So you see it says through-hole C_disk. And I want this thing to have a diameter of 3.8 millimeters. That's this one. A width of 2.6 millimeters and a pitch of 2.5 millimeters. So the diameter and width is actually the dimensions of the actual capacitor. The pitch is how far apart the wire leads are. And so what you can do is you can go to DigiKey, and so I'll bring that up real quick. Let's see, where did I put it? Yeah, okay. So if I bring this up, go to SkinnyRD. So I've got the list of stuff here. So if I were to take and look for that capacitor, so this is the 0.01 microfarad, this one right here, this capacitor. I can go to the DigiKey link, and what it'll tell me is, hey, this is the capacitor that you're using, and it gives me the dimensions right here. It says the dimensions are 3.8 millimeters by 2.54 millimeters, which are pretty close to the 3.8 and 2.6 that we picked, so close enough. And then it tells you the lead here, the lead spacing, right? Oh, I've got a Windows security alert. Okay, I'll take care of that. The lead spacing here, which is 2.54 millimeters, right? So so it's letting us know that those wires are 2.54 millimeters apart. It says here we got a pitch of 2.5 millimeters. You know, 0.04 of millimeters is not really going to make a difference. So yeah, so that's great. So that's exactly what we want. So that's how I kind of pick the library that I want over here. Is I look at the component I want to use and then pick the thing appropriately. If I'm not sure about if this is actually the correct footprint, I can go over here, examine that footprint, and I can get out my little tool over here, the measurement tool on the left-hand side, click from one point, go to the other, and I'll see that, oh, look, it might be hard to see there, but it says X, that I just went 2.54 millimeters over from one side to the other. So I know that that pitch is right, and that's going to work for my component. So yeah, so we're going to double click on that and make that the component we want. The next things here, we've got a capacitor that is the polarity sensitive capacitor. This capacitor, it looks like a can. It's called an electrolytic capacitor. It's the little can-like components. You can go to the list there, find it. It's 4.7 microfarad. The component we want for it is still under the capacitor through-hole library, and it's going to be CP underscore radial. So CP stands for, that's the polarity sensitive capacitor. Radial is just, round. And then it says I want a diameter of 5 millimeters, which is this guy, and I need a pitch of 2.5 millimeters. So we got two 5 millimeter diameters here, but only one of them is 2.5 millimeter pitch. So that's this guy. So double click on him, assigns it. We need 2 LEDs, and conveniently enough, those are located in the LED library. Oh, phone call. Let me turn that off for now. All right. Let me just go ahead and silence the cell phone altogether because I'm busy. So yeah, so now we've got these 2 LEDs take care of. Like I said, I go to footprint library, LEDs, and the LED we want are just normal 5 millimeter LEDs. So you'll find that right here. It says LED 5 millimeter. Just double click on both of those. So what I did is I double clicked for this LED and I double clicked for this LED, so it populated them both with the 5mm LEDs. Good. All right, the next thing we have are all these resistors. Now all these resistors physically are all the same size. They're just 1/4 watt normal resistors. They have different values, but their sizes are all the same. So for this one, I'm going to go to resistors through hole. What through hole means is that means it's a component that has a wire on it that you push through a hole. So resistors through hole is what I want. I want this to be a radial axial component. So you see here it says R axial. That's what I want. Then this Dyno 207. So the Dyno 207, I'm not completely sure what that means. However, the thing I do look at is over here on the side where it says the length, depth, and the pitch. And what I wanted this one is I want a length of 6.3 millimeters. And once again, I got this off of the DigiKey website, off the component. The diameter needs to be 2.5, and the pitch, I'm going to put it 10 millimeters. And the other thing too to watch out for is to make sure that it's horizontal. So what it means is you're going to lay that resistor over on its side. You're not going to have that resistor sticking straight up. I've got some things that I do where the resistor sticks straight up and it's fine. It just saves you space on the board. In this case, we're not really trying to save space, so we can go horizontal. So this is 6.3, 2.5, and 10.16 millimeter and horizontal. So we'll click on that. And I'm going to do this for every one of the resistors. So each one of them is going to get the same treatment. Oh, forgot that one. So 6.3, 2.5, 10.6. Great. Cool. Those all match up. And then the last one is the LM555. That is the chip that we want to use. And so when you're building this thing, you will notice that in the component list that there is an extra component. There is a socket. Just remember when you're dealing with chips and you're doing soldering, you want to solder an 8-pin socket in, and then you want to solder in the actual chip. So if I take and go to, what's that?
Place?
Yeah, and then, yeah, actually don't solder the chip. Yeah, place the chip, please. So I'll show you what that looks like. This is an 8-pin socket. So this is the part you're going to solder in, and then you're going to put the chip inside of this, right? It will seat inside of it and grip it and hold it. You don't want to solder the chip because you risk overheating the chip and burning off things inside of it. So it's better to solder in the socket. What we're doing is we actually are placing a footprint for a socket. Not so much a footprint for the chip. One and the same. They have the same pitches, but yeah, you want to make sure you get the right thing. So in this case, what we're doing is we are looking at I believe it's the housings library. And I don't know why I found it under housing, but housing dip. So these are dip components. So that they're chips with pins off them is probably the best way to describe it. And the thing we want, since our LM555 has 8 pins, is the housing dip 8, and then there's one called W 7.62 millimeter socket. So that is the width of the chip, 7.62 millimeters. And so it says that's an 8-pin chip that is 7.62 millimeters wide. And if I was in doubt about that, I could always come up here, and I was when I was first trying to find these components, click up here, take a look at it, and say, oh yeah, that looks like an 8-pin chip. If I want to look at the 3D component, well, nothing here for me because nobody made a 3D component. But I can measure this out from side to side and measure it out and say, okay, that fits the chip that I'm using, and then select it. So here we go. Double click that, and we're good. So now we've taken and we've selected all of the components that we want for our schematic. Oh, excuse me. I'm going to try to, and see, I'm going to show you down here in the bottom. You've got some selections that you have to do. So once you've selected everything that you need, click Apply and Save Schematic to continue, and then click OK. And it'll save everything off for you. I'll put this back down here. And I'll put my, and let's see I can put my face back down in the corner. Cool. All right, the next thing we want to do is we have to now, since we've assigned everything, what you do is you create a net list. And what this is a list of all of those components you just selected, so that the next software piece, the actual CAD software, the printed circuit board software, knows it's a file that kind of says this component goes with this footprint. So if we click Generate Netlist here, it's saving it as blinky.net. That's cool. Hit save. Great. And I believe that's it. We're good to go with that. After we create our net list, we want to come all the way up here to this little button that says Run Pcbnew. So I'm going to click it. All right, and it's going to open up our PCB making software, essentially. So we've got, this is where we're going to put our footprints down. And the way you do that is you come up here to where it says Tools, click Load Netlist, so that netlist file we just made. We're going to click the folder button here on the side. So up here, going to, just do that again in case I did it too fast. Tools, Load Netlist, click the folder button, and then find that netlist file, which is, it's going to be a .NET file, and hit open. Then it's going to take and load all those components in for us down here, and the last thing we have to do is just click where it says Update PCB. When you do that, it's going to place all the components, and it does give us a little bit of an error there, and we'll work that through in just a moment. And I'm going to click Close. And I'm going to zoom out because now you can see my components kind of follow it around a little bit. If you don't see your components placed, just as soon as you hit OK, zoom out and you'll see your components there. It's kind of a mash of stuff. Take those components, hover it over kind of the middle of that red square, and click, and then zoom in on it. And you will have them all laid out for you there. So there's one other component that we need to place because we're building a kind of a badge. So what we want to do is I want to integrate a logo into it this time, right? Like I want to be place like my logo in it. And like I said on my website, if you're looking at Skinny R&D in the instructions, it was, hey, take and create you, it says choose a simple shaped logo or design that has few colors. The colors, it's not have to be, it should be contrasting colors, and it should be a bitmap. And there's kind of an example right here. And so you could download that if you wanted to, or you could have your own logo. It doesn't matter. So we're going to integrate in a logo with this one. And the way you do that is we're going to need to minimize the program that we're working on here. I'm going to just save it real quick just so it saves my components. I'm going to minimize that. I'm going to bring back up the original KiCad I guess the KiCad main program here that has all these buttons. And there is a button on here called Bitmap to Component Converter. So if you click that, it will bring up a program that allows you to load a bitmap. So what you want to do is click that, click Load Bitmap, and you will need a bitmap file to do this. So if you go to, so for me, what it is, I've got a logo here that I've already picked out that is a bitmap. It's called Just Gears. And so it is a bitmap image. If you don't have a bitmap image, you can take any image, convert it to bitmap, it's fine. And I'm going to open it. And so it gives me this. So the first thing is this bitmap is huge, and it tells me up in the size that the size is 154 millimeters by, so that's 15 centimeters by 15 centimeters. I have a ruler here, if you're looking down in the corner of your screen, that is a 15 centimeter ruler. So that means that if I were to use this on a PCB, the logo would be this large. It's super huge. And so this might look a little bit backwards, but the way you take and downsize this is there is two numbers here that say resolution. And as you increase where it says resolution, the size of the logo will get smaller. So it's really good to start with a large logo and then downsize it. So if I go to 150 and 150, you'll see it just drop to 97 millimeters. So now we're down to 10 centimeters, right, to be the size of the logo, which is fine. But I think I'd rather it be a good bit smaller than that. So I'm going to go up to 225 and 225. And so now we're up to just above 6 centimeters, which is a lot more acceptable for the size of this thing. The next thing I want to do is make sure, actually after you do that and size it right, you want to click black and white picture because this is what it's going to be. What happens is any color image that you bring in, it's going to convert it to black and white. And if you're trying to figure out like, okay, do I want this thing, if it's say red and blue and it's a bunch of different colors, you can set the threshold of what it considers to be white and what it considers to be black down here. And so you can kind of play around with that if you have different colors in your logo to try to figure out what parts you want to appear and what parts you don't want to appear. But it will, like you have to have a black and white image in order to bring it into KiCad. My format, I want my format to be Pcbnew. And also you can flip this to the negative, right? So the thing is right now if I bring this in, everything that's black is the thing that's going to appear in, that's going to be kind of, that's going to appear in my, in my PCB file. Anything that's black is what's going to be printed. And right now this border is black, and I don't really want that. What I want, if I click negative, is it will make this black. Everything that's white will not be printed on the board. So what I've done is I just flipped it from, from being like this to where I'm going to end up with a huge square, to being like this to where I just have a nice smooth circle. So so I'm going to make this to where I'm going to make it negative, make the image negative so that it just prints out this kind of circle component here. Let's see. Let's see. Housing was also under DigiKey DIP 8. Oh yeah. There is some stuff under the DigiKey library as well. You're right. All right. So the last part of this is where do you want this to appear on your board? Most of you are going to want it on your front silk screen. The silk screen is the layer of the board where you can actually print stuff onto. And so that's probably where you're going to want it. So just make sure your front silk screen is there. Last thing you do is click export, and it'll ask you where you want this to export to. I want it to export to my Blinky folder. So the folder that we've been messing around with. I'm going to call this logo. So yeah, so let's say I'll call it logo, because I got a lot of different things called that. I'm going to call it logo Blinky. All right, so logo Blinky, saving it in the Blinky folder, hit save, and we're good. Get out of there. Now I'm going to bring back up the Pcbnew program that we were messing with where we have our footprints. And what I want to do is go to preferences. Actually, let me just check something really quick and see if it decided to do it for us automatically. I don't think it did. Nope. All right, cool. So what I'm going to do is go up to Preferences, go to Manage Footprint Libraries again, go to Project Specific Libraries. Once again, click on the folder, and this time I'm going to highlight where it just says Blinky. I'm not going to highlight this. I just want to highlight Blinky. I'm going to hit OK. And what that's doing is saying, hey, look to see if there are any footprints in the Blinky folder. Hit OK. Go back over here to where it says Add Footprints. Click it. Click into the space here. And let me see where I put it. Yeah, here it is, under Blinky. So, so under the name of the folder that we clicked on, so under Blinky, if I click it, it says Logo Blinky. Shows my logo there, hit OK, and then I can place this in the field wherever I want it to be. Cool. Now it's down to placing all of these components. So, so you might want to get you some space here. I'm going to try and see. I'm going to highlight all of these components and kind of move them out of the way. If I hit M, I can move them all. I'm going to hit M on this logo, or actually click on the logo, hit M, and move it to the center. I'll take these guys, hit M, move them back. So just kind of making me some space. So now I'm going to build my PCB around this. The first thing I want to do is I'm going to kind of click M here and separate out some of these components so I can see what I've got. Make sure you've got your little arrow clicked here. Also, if you're moving stuff around and you accidentally hit a label, you'll notice just the label moves. If you do that and you're just stuck and you're like, I don't want to move the label, just hit escape and it'll move the label back to where it was supposed to be. But click on the component and just kind of move stuff around. I've got my two diodes. I think I'm going to put those down here for now. I've got my capacitors. Move them over here. Get some of these resistors out of the way. All right, cool. The first thing I'm going to play with is I'm going to play with my battery. So this battery has a couple of through-hole components here. So if you remember, here's the battery that we used on the proto board earlier when I was showing you schematic, and it's got those two little pins that come out the bottom. So at first when I was looking at this project, I was like, oh, well, I'll just take the battery and I'll put it on the back side of this logo. But then I was like, I don't want those pins sticking out through the logo though. So what I'm going to do is I'm going to take and rotate this battery around. I'm going to place it just under my logo. And right now you'll see that it is set to be on what we call the front copper layer. So it is, if you look at the actual labeling here, so it says BT1 in green. If you look at green, well, this green color is the front silk screen color. So I can turn it off and on. So that means that this thing is on the front. So it's going to be printed on the front. It's going to look like it's on the front. I don't want that. What I want is the battery to be on the back side of the board. So what I can do is I can click on this component and right click and go to properties. Or better yet, instead of going to properties, let's do it easier. Another way you can do it is just click on the component and hit F and it will flip it to the back side. Then I can hit M and move it back around. And now you'll notice that it says BT1, but it's written backwards. That's because it is now, if I go to the back silk screen and toggle it on and off, it is on the back of it. So it's written on the back side of the board, which is where I want it. Now these holes are still going to penetrate through all the way through the board, but this kind of reminds me that, hey, you're going to mount this on the back of the board. And if you hit F again, it'll flip it back to the front side of the board. It's completely up to you and where you want to place your battery. The other thing, before we get going any further, is you'll notice that a lot of these components that have, it has these values underneath it. So it says 10K, 220K, 470, like all this. All that stuff in gray there is the front fab layer and the back fab layer. Those don't get printed. Those are just there to let the, if you were sending this to a manufacturing house and they want to know what the components should be, you're just kind of letting them know. Oh, sorry about that. But we can turn those off for now because those aren't actually going to get printed on the board. So you can leave them on or turn them off, but just know that whatever you do with them, they don't get printed on the board. So just to kind of give you a heads up there. So now we can place all of our other components. So if I go to get my little cheat sheet out here because I've done this before and I figured out where I wanted these things. I'm going to take my chip and I'm going to move it to kind of the center line here. I don't like my labeling for my chip to be outside of the chip, so I'm going to drop that to the middle. I am going to then take some of these other components and then place them. So you remember these wires, what these wires mean is these are components that are going to have to connect at some point, right? And so what we want is we want to place these components as close as we possibly can to the places where they're going to connect to. So I've got, right now, I've got the capacitor that's going to be connected, it looks like, to the 5th pin there to some degree. And so maybe it would be nice to place this here. Looks like a good central position. I'm going to place, say, R1. Looks like R1 wants to go to pin 8 there, so I'm just going to rotate that guy around and get it in there kind of close. There we go. R2 looks like it wants to connect to R1 and another pin close there, so I'll probably put that in there. Also, you can move these labels around so that you know which ones they belong to. So it looks like R2, yeah, this is R2 and this is R1. There we go. Keep the labeling good. I've got C2, which has some components that looks like they would connect well on this side. So I could go, yeah, that looks like it'll be good. So I'll put it there. And I'm going to take the label, rotate it, and move the label up. There we go. I've got a, all right, so that was C2. Okay, and now we've got the 2 diodes. So the diodes, I kind of want to have some fun with these. So I'm going to put one of these diodes right in the middle of my gear symbol here. Do the best I can to place that. And I'm going to take the other diode and do the same. Cool. And then my 2 resistors that go with those diodes. So I'm just going to try to pick a place that works well there. I might have to draw a long line, but that's fine. I'm going to put one resistor here. And the other resistor, where do I want this guy? It looks like, oh, that's where I put it last time. So I'm going to move these down. Oh. And move this guy down. All right, so, I mean, on yours, right, feel free to draw them however you want. Like, the big thing is just placing these components. You know, placing them where you want them. You know, now you can see why I decided to put the battery on the back side, right? Like, I like the ability to use the space. I don't want, if the battery's on the front side, then all of this space where I'm putting these components just be in the way. So the thing you got to think about here, though, is that I'm going to have a battery holder, right, like this. I'm going to have this battery holder on the back side. And this battery holder, like, if I solder this, I don't want to solder this on first, right? If I solder this on first, then most of these other components aren't going to be able to go down because I've just covered the back side of the plane with a big piece of plastic and I'm not going to be able to solder these components on. So what I'm going to have to do is solder all of these front components on first and then take advantage of these long pins on this battery holder to come up from the bottom. And after I've soldered everything on the front, then I'll solder this onto the bottom and I will have a place for my battery to go. But you just want to make sure that you do that because you don't want to plan this you know, wrong. You don't want to take and put the battery holder on and then be like, oh crap, now I can't put any of my components down in it, right? So you don't have to do this either though. You can just flip the battery on the front side or you can just move all the components around so that they don't intercept the battery at all. It's completely up to you. The thing I'm going to do now is I'm going to draw my wires real quick. So I've got all of these components that need to go together. And I'm going to draw these kind of quickly. So I've got a bunch of grounds here that need to go together. So this to this. So what you do is you just pick the wire tool. You click on the component that you want to connect, and then you take your finger off the button, drag it down to where you want to go, click again, and you've connected those 2 points. And there is a bunch of stuff to connect here. So I'll just run through some of it. So here, it's going to go to here, and then, all right, so now we've got a problem, right? So I want to go from here to here. So I could do this little weird thing here where it loops down and, you know, kind of crosses under. But what I'll do instead is I will flip to the front copper. So you can draw these wires on the front or the back. So you can click one of these or the other. So I'm going to click the front, go from here, go right over that wire to there. So one of these, the green is on the bottom, the red is on the top. The one thing I do want to make sure though is my wires that go up here to the logo, I want to make sure those are on the bottom, just because I don't want those to appear. They can appear, they're not going to appear over the logo anyway, but I just think it kind of looks nicer if they're on the bottom where the logo is. So I'm going to do as much as I can to keep these on the bottom. And this one too. Cool. And hook all of these battery stuff together. So you hook that up. Hook that up. So, yep, all I'm doing is just going through, just placing components. This looks like it's going to need to be on the front. What some people like to do is they like to say, okay, well, all my horizontal wires are going to be on the front, all my vertical wires are going to be on the back. It kind of helps to just kind of come up with a system that works, and that's fine. However you want to do that. See, we've got a couple more here I need to fix. So here to here, and then here to here. All right, cool. And it looks like when you get them all sorted, what will happen is down at the bottom, you will have a number in the bottom left-hand corner. It says unrouted. And when that number says 0, you have been successful. However, there is one problem left on this. The battery component that we picked, you'll notice that there is no wires running to the positive or to the negative. That's because the DigiKey library, most libraries, what they do is they label all of their pads, all their connection pads with a 1, a 2, a number, right? Well, when I went to the DigiKey library, look at this, they did not label it with a number, they labeled it with the words positive and negative. And that doesn't line up with our schematic. The way I found that out was if you go to where it says load Netlist, you'll see that when we loaded, we had 2 errors. And it says that pad 2 is not found on the battery coin holder thing, and pad 1 is not found on the battery coin holder. So what we have to do is we have to make sure that the schematic or the layout knows that we need to connect to negative and positive. Now, one way we can do that is we can just force it, right? Like we can just say connect this to here and call it done. But even that's problematic. So the way that you really settle this is take and click on, we'll start with the positive pad. Click on the positive pad, right click on it, and go to properties, okay? You will see that there is a thing under properties for the positive pad. It says net name. Or actually, no, I'm sorry. That is not what I was looking for at all. Give me 1 second to remember where this is at. I'm doing this live. Yeah, pads. Sorry about this. It should be there. There was a place on here where I was able to change. Sorry about this. It is taking me a little bit to remember where I did this. Let's see. Okay. So let me double check. Yeah, so what I'm looking for is there is and if you're out there in the comments and you see how to do this, there's a place you can go to and you can change this so that it will meet up with the with one of the, pretty much you can tell the pad, hey, you're supposed to connect this particular layer. And I'm sitting here trying to look at it and figure out what that, where that was. Anyway, push comes to shove. Here's the way to kind of solve it as well. So what you can do is take the battery itself, right click on it, and what we're going to do is we are, let me see, yeah, what you're going to do is take the battery, highlight it, or click on it, and you'll see the battery in the background. Everything will highlight. Double click on it, and there will be a thing that says Edit Library Footprint. So you can click that, and it will bring up the actual footprint, and you can edit it. So the way we're going to edit it is I'm going to take where it says positive. Instead of calling it positive, I'm going to change it to 1. Negative, I'm going to change it to 2 and hit OK. Now we might not want to save, you can save this straight back to the library if you want to, but the main thing that we want to be able to do is, yeah, so what we'll do is we'll save the changes to the library so it makes those changes for us. And then what we can do is go to Load Netlist and update the PCB. Oh, it still didn't do it. Dadgummit. Well, I am sorry. I have dropped the ball on this one. Oh, there it goes. Okay. I don't know why it just did it. Okay. So anyway, once you do that, what it does is it refreshes it, it looks like. So here we go. So now what you can do is you can double click on the net name. You'll see a drop down, and for the negative side, I'm going to click ground. For the positive side, I'm going to click battery positive. And so now, once you do that, you're going to have those wires get dropped in there. For some reason, yesterday when I did this, what it did is it took and it allowed me to do that right away. Just go in there, double click on the pads, and select battery positive for positive, and then G and D for ground. And you'll notice that once you do that, you got the lines that pop up there. So if you, now I can take and I can go ahead and draw these last two. Sweet. So I can draw those last two, and I've got everything connected. The one thing that I have left to do is now I have to draw a board edge. So I've got to be able to take and make the board outline for what we want to print out. And there is 1,000 ways to do this. The simple way to do this is to take and click on Edge Cuts, and then click on Add Graphic Line. And what I'm going to do is start up here. I'm going to create a line over, and essentially I'm just going to draw a big box, right? So I can draw it from here to here. Maybe I'll come over and then come down, come over, and all I'm doing is everywhere I want a joint, I'm just going to click.
Is that problem in videos?
Oh, okay, it fixed itself. Okay, yeah. So just drawing this out. Bring it up, bring it over. Once you finally kind of end it, what you want to do is make sure that you have this where it matches up. You'll see this little bull, you'll see like a target symbol that comes up, and that lets you know that you've matched up both ends. Click it, and then you've got your board outline. You can get more fancy than that. So let's say, for instance, I'm gonna delete these top two. Let's say I wanted a holder so that I can put this on a necklace or something, right? So what I could do is I could take and match this up. Oh, nope, sorry. See, there we go, yeah. So click here. I can draw my trace over. I can go up a good bit, go over this way, go back down, and then come over, match this back up, and have a little notch there. Then what I can do is place a footprint. So there's an interesting, let's see, where is it at? Connect. There's a 1 pin. So pretty much you just put a pin in the middle. So that was under, in case you didn't see that. You go and place a footprint. There's one called connect. And under connect, it says 1 pin. So all it is a hole, right? So you can click that, right click on it, or better yet, oh, sorry about that. See, go to the mouse thing, I can double click on it, it brings up properties. And I can say, hey, I want this to be a non-plated through hole, that's MPTH. So that means just give me a hole. And I want it to be circular. And I want the size of this hole to be, let's say, 200 mils. The hole size up here, 200 mils, just make a match. And so now I've got a 200 mil hole I could run a string through, right? And so now I've got myself a necklace if I want it. The other thing, if you want to get really crazy, and I'm just going to leave this like this for now, but you can add, graphic circles and stuff. So if I go to Edge Cuts and click Add an Arch, I can come to the middle of this logo and get it just right in the center. It's really tough to do. Click, drag this over, click, and then make a gigantic circle around it, right? Or just an arch that goes, part of the way. So another way we could do it is I could click in the center and get it all centered up. Click it, come down here, click. Oh, I went in the wrong direction. I should probably went the other way. So these tools would take a little bit getting used to. So click down here, draw it all the way around, click right here. And then instead of having these large edge cuts around, I can do something like this. So I could take these out. This out. And then make it to where the edge cuts connect up to here and here. And of course then I would have to redraw the top part here, the little necklace part, right? So I would need to kind of integrate that in somewhere. But now what happens is I've got a more uniform shape. And so a lot of times what happens is a lot of people don't draw the wires in until they make all the edges and make it to where they want it. Because now what happens if I wanted to line up my logo a little bit closer, all I would need to do is hit M, and then I could drag this thing around. But right now with the wires already drawn, it would be hard to drag the logo around. Well, actually I can drag the logo around. That shouldn't be a problem. It's just the diodes that I would have to move to line back up with the logo. So you can play with this forever, right? So like the edge cut thing is just something you can keep playing with and keep playing with. Once you've got everything like you want it, you can come up here to this little bug, click it, and hit Run DRC. And it gave me a few errors. It said, okay, like it looks like you're too close. So it's telling me that my my wires here, so this wire and this wire, yeah, pretty much this wire is just way too close to the edge of the board. So I can delete this out. We'll go to our wire here. I'm deleting that wire out. And then all I gotta do is just redraw that wire. We'll say through here this time. And go back to my design rules, run DRC, and no errors anymore. I can list to see if there's any unconnected, and there's not, and it looks like it's good to go. Cool. I got your there in the comments, D. Ollinger. We can definitely answer questions after we're done. So there's so we made this kind of put this thing together. So it says, how do you change from route on the front to the back? I'll show you. So if you want to change the route for a wire from the front to the back, so let's just pick this one here, right? I can take a wire, and let's say I'm going to stay front. Let's see our wire here. So let's say I'm on the front copper and I'm running my wire, and then I want to switch to the back. What I can do is right click in the middle of the run and put place through a via. And what it'll do is it'll drop a hole, not a full open hole, but just kind of it's a penetration through the PCB to go to the other side that's just solid copper. I can click that, and then coming off of that, it'll drop to the other side and let you run the wire. So that's how you can route the front to back. And you can keep dropping these things, they're called vias, over and over and over again, flipping from one side to the other as many times as you need to on a route. So that's one way, definitely, to do it. Like we did last time, if you wanted to then see what this would look like as far as like what this would look like as a PCB, you can go to the internet and go to OSH Park, browse for files, and go to your Blinky folder, and you want to upload the blinky.kicad PCB. It'll upload it, and it'll give you a rendering of a pretty good rendering of what that PCB is going to look like. So just give it a second here. There it is. So that's what my PCB would look like right now. My LEDs are a little off center, but that's fine. And I've got, this is what my top view looks like, and there's my components and stuff. And I've got my, at least I can see the holes for where the battery would go on the back side, and kind of where everything would be printed. So yeah, it turned out pretty good. If I wanted to get this ready for production, and send it to something like JLC PCB, and they require Gerber files, remember? So if you go to File and go to Plot, these are the several things that I recommend having on there when you send it off, especially with just simple PCBs: the front and the back copper, front and back paste, front and back silk screen, front and back mask, and edge cuts. And I don't even think the paste needs to be there. So that's questionable. But then you just click Plot. You also need to generate the drill files. So my settings are the PTH and MPTH in a single file, Excelon, PostScript file format. I can generate this file, hit close. And then the final thing all you need to do is open up that folder, go to your Blinky folder, and every extension that has GBR on the end of it, you want to highlight. So I just hold the control key down and highlight everything that says GBR, and then the drill file as well, and just send to a zip file, blinky.zip. So now I can go to, open up a new one here. I can go to JLC PCB. I need a 2-layer board, so I'll get a quote now. Add my Gerber file, which is the zip file that we just made. Uh-oh, looks like they're kind of busy at the moment, so I'll get back to it later. But yeah, you just upload it there, and then you can see the same sort of layout that you see for PCB, OSH Park, I should say. I do want to show you one thing real quick before we end here. So this is just kind of like I said, just kind of basic, just playing around, just trying to figuring out how I want my badge to look. I do though have, I'm going to exit out of here and save it. A badge that I've been working on for a colleague. He's just started his company, and he's doing some courses. I'm going to be providing a course, actually, depending on how Black Hat decides to arrange your courses. But there is a, let's see, where did I put it? Yeah, there it is. So this is a badge that we made for him. Turn off some layers here. So his is a wolf, right? So, so he very delicately took and traced out all the edges on this, kind of really fine, trying to make sure that he got as much in there as possible. He probably had to go back and do some stuff. This is just kind of rough outline. I think he even took some time to make it even closer. But what we did for his is we used surface mount components. So this is a badge. They call it. I think it's a particular type of badge piece when you go to DEF CON that fits on to other badges, so you can light up your own badge. So like this is kind of a standard component here. These 6 little copper pins. And what we did is we put, let me turn off the front silk screen, we put his LEDs on the back and their surface mount. And what we did too is these diodes are actually not facing away. These diodes are on the back, but they're facing towards the PCB. Because what we did is at the eyes, and this is something that you might want to look up or mess around with, but with the eyes what we did is we put in exclusion zones. So in other words, what happens is in these particular zones where the eye slits are, there's no copper, there's no mask, there's nothing. There's not a hole there, but there's nothing on the actual PCB to disallow the light from shining through the PCB. So what's going to happen is when you plug his up, you're going to be able to see that the wolf eyes are going to glow at you. So it's kind of cool little badge project, and he's about to order kind of the new batch to figure out what he wants to do, or to try a new batch of them. And we tried the first batch, and for whatever reason we had not put the silk screen in. We had left the silk screen off, excluded that, but forgot to put the exclusion zone in for the copper. And so what happened is the copper covered up all the light, and you couldn't see the light through the PCB. But yeah, you can get a logo and kind of import it in, and then just kind of make it elaborate as you want. So if you have a business, or you have like you're trying to represent your office with some sort of symbol, or you have some kind of logo or something, and you want a cool little PCB project, probably do what we just did, but use surface mount LEDs so they're kind of low profile and don't stick out real big, and you could come up with some really cool designs to play around with. Yeah, so that's it. Thanks looks like we had about 20, 25 people in today, so cool. Thanks for you guys for showing up. If you have any questions, I can take those now. I am going to kind of kill, I guess, I'll leave the live stream up for a little while for anybody who has any comments or questions or anything like that. And if you want to talk to each other, that's fine. But thanks for attending, and I'll see you next time, and hopefully we'll see what might go away from KiCad next time and play with something else. But let me know in the comments too if there's any particular thing you'd like to see live streamed, and we'll work on it. All right, cool guys. I will see you later. But I'll be hanging around.